Is this good? Oh, okay. Now, I'll be teaching you the basics of trigonometry. Meet your new best friends, sine, cosine, and tangent. These are the main functions of trigonometry, but there's specifically types of ratios between the lengths of the sides of the right triangle. The sine of an angle is equal to the length of the side that's pretty much across the angle in comparison to the longest side of the triangle, which is the hypotenuse. In simpler terms, the sine of an angle is equal to the opposite over the hypotenuse. The cosine of an angle works similar to sine, but instead of the opposite side, we would be using the length of the side that's touching both the angle and the right triangle, which is called the adjacent. Tangent, however, works a different way, because instead of using the hypotenuse, the ratio would just instead be the opposite over the adjacent. It's good to know that like whatever is on the opposite of the angle is the opposite, and whatever is like next to the angle is adjacent. If it ever helps you, you can always refer to these ratios as you start to get used to this. Now, here's how you input these in your calculator. If you wanted to calculate for sine, let's say we're calculating with an angle of 90, we would hit the sine button, and then it will show up with sine in the parentheses, and we just type in 90, and then poof. Originally, these like sines, cosines, and tangents had calculations in the textbook, which is something nobody kind of uses anymore. But they had like specific numbers for like any sort of angle for like either sine, cosine, or tangent, and you would have to like skim through your textbook and look for the number value, and then you would just like input that in your calculator, and then boom, there was your value. Nowadays your calculator does that for you. Now we're gonna do some questions, and it's all gonna be worthwhile. See, let's do this one. The length of the side that we are given is 17, and we are looking for x. Now if we look at it, our angle is right here, so then that means x has to be our opposite. I would like setting this up first, so when you're writing it on paper, I would recommend that you outline it like this. Since we have the opposite and the hypotenuse, we are using sine, so we would write sine 59 equals, and then for direction, on the top you would say x, then on the bottom you'd say 17. This looks like basic algebra where you have to isolate your x value. So in this case, you would multiply 17 on both sides to isolate the x. So then x would equal 17 sine 59. That sounds like a mouthful, right? Well, calculator is gonna help. Now, to solve for x, we would just type 17 sine 59, close parentheses, bada bing bada boom. Your x value, assuming that you're rounding to the nearest tenth, is 14.6. How about a question where we're looking for the angle measurement? See, our angle measurement is right here, and we are given the values of 13 as the adjacent because it's next to that angle and is touching the right angle, and 4 because it's completely opposite of the angle that we're looking for. That means it's the opposite. So when you're writing this out, it would be tangent theta equals 4 over 13. So you're probably thinking, what do we do now? Easy. In the calculator, you hit the second button, and then tan, that will give you tan, -1, and then 4 over 13. And then your answer would be, assuming you're rounding to the nearest tenth, 17.1 degrees. What if you're looking for a value that is on the bottom of the ratio? Well, we're going to look at question 13. We are given an angle measure of 41 degrees, a side length of 4 being the opposite, and a value of x for our adjacent. That means we're using tangent, so we will write it out as tangent 41 is equal to 4 over x. This kind of has like a direct relationship, direct to the point where you can kind of just like flip it, like switch the x and the tan 41. The long way could just mean multiplying x on both sides and then dividing by tan 41, which is kind of unnecessary when you can just like switch it. I learned that the hard way. So in the calculator, we would put in 4 divided by tan 41, and then our answer in this case would be 4.6. A lot of trigonometry errors typically occur within the calculator. Nothing wrong with the calculator, just you inputting it. Your calculator has to be in degrees. If you're ever unsure on whether your calculator is either in degrees or radian, if you have a TI-84 calculator, turn on your calculator and hit the mode button. Go to where it says either radian or degree. If degree is highlighted, your calculator is in degree and you're ready to do some trigonometry. I've gone through this and let's just say, help. Next problem. Some people often organize their data with the wrong ratios when they're inputting it to the calculator. It's often people confuse what length goes over what, and this usually happens as they're developing their trigonometry skills.
Oh, if we're looking for the sine, the opposite length goes over the hypotenuse, or whatever.
It takes time getting to know those ratios by heart. You might be wondering, how is this even applicable in the real world? I thought the same thing myself until I just Googled it. Trigonometry is often used in physics. Wow, what a shocker. Just look at all of these worksheets that I've amassed that have involved trigonometry in my physics class. In all seriousness, this can be applied when you're calculating things like height. Just like this idiot. Roll the clip.
Oh my gosh, look at that shadow. I wonder how many degrees it is off the pole. How will I ever find out? Oh my god, it's a pole. Oh my god, it's a pole. How tall is that pole?
Easy. Measure the shadow and the angle of elevation, which is the angle which you see the object from the end of a shadow.
How do I do that?
Easy. Use a protractor and raise your head until you see the top of the tree.
How do I do that?
Shut up! And if you're like me, trigonometry can be used in the field of music as well. Trigonometry helps when placing instruments. You want the sound quality to be clean and concise, so placing instruments helps distribute the sound evenly. So where you have multiple different instruments playing different sounds, knowing where to place it helps make the performance sound 10 times better. And a calculation doesn't really apply here, but professionals are often aware of this capability. Except I'm no professional. So, what did we learn here? That the sine is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. And tangent is the opposite over the adjacent. Oh, that's really good. How about you?
So, to solve for an angle measurement, you hit second and whatever function with the ratio of side lengths accordingly.
Okay, we're getting somewhere. How about you? That this entire bit was just pointless. Well, you're not wrong.